Dear students, under the topic Evaluation of Integrals using Laplace Transform, here we have problem 2. The question is, evaluate integral 0 to infinity t e to the power negative 3t cos t dt using Laplace transform. So we have to use Laplace transform in order to evaluate this integral, for which first we have to write the definition of Laplace transform. By the definition of Laplace transform, we have L of f of t is equal to integral 0 to infinity e to the power negative st f of t dt. Now we have to compare the given integral with the definition of Laplace transform. So what is the given integral? This given integral can be rewritten in this form. So first we will write e to the power negative 3t. So this integral can be written as integral 0 to infinity e to the power negative 3t, and then we can put the t and cos t together as one function. So t cos t dt. So now if we compare with this integral from the definition of Laplace transform, it is same integral 0 to infinity e to the power minus st, and here it is e to the power minus 3t, which means the value of s is equal to 3, and f of t is t cos t dt. So therefore this can be written as L of f of t. So by the definition of Laplace transform, this integral can be written as L of f of t, where f of t is t cos t. So therefore L of t cos t, and the value of s is equal to 3. That we will be substituting after finding L of t cos t. So let us mark this as equation 1, and let us first find what is L of t cos t separately and then substitute over here. We now have to find L of t cos t. So by the second theorem, we know that L of t f of t is equal to negative d by ds of L of f of t. So this we have learnt in our previous video lectures. So we will be using this now. So we have to find L of f of t. So therefore that is L of t cos t. So this will be equal to negative d by ds of L of f of t. So when you compare these two, we see that at the place of f of t we have cos t. So cos t. But we know that what is L of cos at? By the results that we have previously learnt, we know that L of cos at is equal to s divided by s square plus a square. So now we are going to use this result at this place. So when we apply over here, we get this to be equal to negative d by ds of L of cos t. So at the place of a, we are having 1 over here. So it will be s divided by s square plus 1 square, which is 1. Now we have to differentiate this by using u by v method. We know that the differentiation of u by v is equal to, in the denominator we have v square and v multiplied with u dash minus u multiplied with v dash. So this formula we are going to use here. So what do we have at the place of u? At the place of u we have s, and at the place of v we have s square plus 1, and so u dash will be, differentiation of s with respect to s is 1, and v dash will be equal to differentiation of s square, which is 2s, and 1 is a constant, so when differentiated it becomes 0. So let us substitute that over here. So therefore this will be equal to negative of, so in the denominator you will be having v square. V is s square plus 1. So s square plus 1 the whole square, and in the numerator v multiplied with u dash. What is v? S square plus 1, and v dash is u dash. V multiplied with u dash is 1 minus u multiplied with u is s multiplied with v dash is 2s. So we have already solved these kinds of problem in our previous video lectures. If you would have followed it, you will understand this more easily. So negative multiplied with, so when s square plus 1 is multiplied with 1, you get s square plus 1, minus when s is multiplied with 2s, you get 2s square, divided by s square plus 1 the whole square. Now further this will be equal to negative of s square minus 2s square will give us negative s square plus 1 divided by s square plus 1 the whole square. Now when this negative sign is multiplied inside, we get minus into minus becomes plus, so s square minus into plus is minus 1 divided by s square plus 1 the whole square. So therefore we have obtained L of t cos t. Now we have to take and substitute this L of t cos t in our equation 1. So at this place we have to substitute. So after substituting, what we get is this. So this is L of t cos t. So I have taken and I have substituted in equation 1. Now if you see, the value of s is 3. So putting s is equal to 3, we get integral 0 to infinity e to the power negative 3t t cos t dt is equal to, so at the place of s you have to put 3. So 3 square is 9 minus 1 divided by 9, 3s square is 9 plus 1 the whole square, which is equal to 8 divided by 9 plus 1 is 10, so 10 square. And so therefore the answer will be equal to 8 divided by 100. And this can be simplified and it can be written as 2 divided by 25. So this is the answer. So therefore integral 0 to infinity, we will write as we have in the question, t e to the power negative 3t cos t dt is equal to 2 divided by 25. Hence we have evaluated the required integral. Hope you have understood this problem. In our next video we will do a similar problem, that is problem 3, where instead of cos t we will be having sin t. So with that, the problems under the topic of evaluation of integrals, I hope you will be thorough with it. So kindly follow the next video lecture for one more problem under evaluation of integrals using Laplace transform. Thank you.